All right, so thank you for coming to my talk. I'm going to be talking about GUIs, but I want to set a bit of a motivation before I get into that. Because programming is very text-oriented, and I think particularly Scala developers are very kind of terminal-oriented. So why are GUIs interesting? Well, for me, I happen to really like anything graphical, and I really like GUIs. So I'll give you an example of something I created fairly recently. Is this little GUI, which we used in Scala Bridge yesterday. And what this is doing is showing the relationship between a parameter, an input parameter, controlled by this slider, and an output, which we call the loss. And this is something we try to optimize in gradient descent. So this is a teaching tool to try to make the fairly abstract concepts of gradient descent a little bit more concrete for people so they can see the relationship between this input, which we're trying to optimize, and the output, this loss, which is the objective of the optimization. So that's GUIs. For me, they're useful in lots of places. I really like them. But what about you? Or why do I think you should care about GUIs? So let me start the story. I'm going to talk about a developer who I expect is quite a lot like you. Oops, wrong way. Probably better than me, because this developer is very competent, and I obviously, a little bit incompetent here, very calm, very capable. So someone who can tackle any bug and fix it, can implement any feature, a virtually unstoppable coding machine, except for one thing. There's one thing that can slow them down, and that is these people, the non-technical people. John from accounts and Chloe from marketing, and they have this magic skill that could destroy productivity. And what this is this phrase, could you just run this report for me, get me this data? Could you just take a look at this issue we've got here? Could you just help me with this request that's come in? And, it's not really their fault. They don't know how to code. They don't know how to use Git. They don't even know how to use a terminal. They're basically alone in this digital world. They're not developers, so they can't use software. So every time they want to do something that involves systems, they come to the developers. But it's a real problem for the developers who are constantly interrupted and can't get anything done. And this is organizational failure, really, and it's a failure of internal systems. So what do I mean by internal systems? Internal systems are systems that are used by people inside an organization. So that's the kind of system that John from accounting or wherever he came from, I forget, could use to solve his own problems if there was such a system. So we're talking about something that has a GUI that the end user can use. That doesn't require coding, doesn't require getting the terminal, doesn't require entering a bunch of Unix commands to get something done. And I've seen many companies, I work as a consultant, so I go to a lot of different places, and they typically underinvest in these internal systems. And the reasons given are usually, something like the following. We don't have the resources to do it, we don't have the time to do it, and usually the backend developers recognize the need for these systems, but they're not capable of doing it themselves. And there's often an organizational problem where you have, say, front-end is split from back-end, and you think to build, say, the GUI interfaces, you need some front-end developers, and they're not willing to commit their time to help you out. Or sometimes it's, you have short-sighted management that's focusing only on immediate delivery, not thinking of the longer term, how can we optimize the organization as a whole. So this is quite a prevalent problem I've seen. So I thought to myself, well, I'm interested in implementing GUIs myself. I need this GUI library for the things I want to do, and I've seen this problem, so can I try to solve this? Can I implement a really easy-to-use GUI library? Well, that's what I've been attempting to do, but the question you get from this is, what does it mean to actually be really easy to use? What makes code a delight? What makes code so simple that you could just knock out a GUI in an afternoon and ship it and get this internal system done? So let's look at that. What is it about code that will make it easy to use? And to do that, we're going to look at code as an interface. So code is an interface. It's a way to interface with the computer. And we have a field that studies interfaces to computers, and that is human-computer interaction, or HCI. So HCI studies how people use computers effectively, using the context of different interfaces rather than coding. But can we try to apply some of these principles from HCI to code? So I'm going to talk now about some HCI principles, 3 of them, and then I'm going to talk about how they can apply into code. I'll show some examples. So the first principle I want to talk about is progressive disclosure. I hope you like that visual pun there. We had progressive disclosure of the title. What does progressive disclosure mean? Well, I'll talk about that in a second. I'll just give you an example first. So progressive disclosure is used in lots of user interfaces. Here is the print dialog in my web browser. So this shows only a few options, the most common options, and it says if you want to do more stuff, then go to the system dialog. So we have this link which I've highlighted here, drawn the oval around. And this dialog is a big chonker. It's got loads of stuff, all these different options I can set. So the idea here is, for most people, most of the time, I can use a much simpler dialog. I don't get overloaded by all these choices. But if I want all of the extra choices, they're available. I can go to this more complex dialog and do just about anything I'd want to do with, in terms of printing in this big dialog. So the core idea of progressive disclosure is hiding unnecessary information. Only show people the stuff you think they'll need to solve the problem at hand, but give them the option to get more information if they need it. We saw that in the user interface. That's one way of doing it, and we'll see lots of examples coming up. Okay. The next principle I want to talk about is consistency. So let's see that in the context of user interfaces again. So here we have the menus from a few of the applications on this laptop, and we can see they all have the same kind of structure. We have the Apple menu, we have the named application, a file menu, and an edit menu. It's an example of consistency, things being the same. And why is consistency useful? Well, the idea here is we can reduce unnecessary information, reduce the amount of learning the user needs to do, because they can transfer knowledge from one domain to another. So if I learn where the preferences are hidden in Slack, out of the Apple menu normally, then I can transfer that knowledge to Firefox and find the preferences in the same spot. So consistency just makes things easier to use because you don't have to learn every particular case as a unique special snowflake. You can reuse knowledge. The third principle I want to talk about is discoverability. So discoverability is how I find things. I think it's fairly obvious in the case of GUIs. I have menus which have the options I can choose. I have toolbars which have the tools I can use. So I'm going to show here an example that's text-based and closer to what a lot of us developers work with. So I have here an example of fuzzy search from Emacs, which is obviously known as the world's greatest editor. All right, a few Emacs users here. Didn't hear any booing from the Vim users. That's good. So this is an example. I'm searching for functions that have the name yank in them. Yank is a term in Emacs that basically means pasting things in modern terminology. But of course, Emacs predates the modern terminology by a few decades. So if I want to yank something, I can just go Command X, Meta X, and search for yank, and I have all of these options here. So this shows me all of the possibilities that are available for this term. So it's a way of discovering a huge amount of functionality that's in Emacs. I wonder if I dare take this off. It's getting rather annoying. Okay. In a very simple way, it's this search. All right, so the key idea of discoverability is how do I find new information? How do I learn new things to solve the problems I don't currently know how to solve? All right, so 3 principles of HCI. We had progressive disclosure, we had discoverability, we had consistency. Now I want to see how we can apply these principles to code. And I want to also show how we can leverage Scala 3 to make software more usable. So into GUI. So GUI is this library I've been developing that's for creating user interfaces. very witty name, obviously. And the idea behind GUI, as I've explained, is to make things really easy to use. That's one of the core ideas. And the other idea is to get good enough done quickly. So for the typical application I'm thinking of, the backend developer internal system, the GUI doesn't need to be amazing, but it needs to be good enough. And the idea is, how quickly can I make something which is good enough? So let's start at the beginning. Starting point with any code is importing something from the library to use it. So in GUI, there's a single import, GUI.all.star, and that gets you everything you need to use. So you don't need to learn the structure of the packages, where stuff is hidden away, in which package to get using. You just import this, and away you go. So it's an example of progressive disclosure. When you're starting out, you don't care about the package structure. That's irrelevant to you. You want to get your job done, not learn this hierarchy of packages. So we say you don't need to know. You can import things on a per package basis if you want, if that's something that you think is useful. But it's there as an option if you want to take it. You don't have to do it. You can just do this one, get me everything in one shot, and away you go. And this is made possible by Scala 3's export declarations. So you create this object all, and we can just export all the things that we want to make available here in one go. So really neat feature in Scala 3, and it's in some ways a very trivial application, but I think it really helps to make this just getting started process a lot easier. Okay, so we've imported GUI, and we want to actually go about creating a user interface. So we have some data, say a user has a name, it's a string, an age is an int, very simple, for example, and we want to create an interface to capture this information from a user. How do we go about doing it? Well, we need two lines, driving component, and then we can build a form based on the type here. And that form will look something like this. The rendering is a little bit messed up by the slide template, and we can go and enter some stuff. As you can see, it's not the best interface we could have, but it certainly does the job. It might well be good enough. And submit. Okay. So this, again, is an example of progressive disclosure. There's a whole bunch of stuff going on within GUI, its internals, but you don't need to know about that. You don't need to know how we construct user interface components. You don't need to know how they're laid out. You can just use this generic derivation tool to create a reasonable user interface with a very minimal amount of code. And this is made possible by Scala 3's generic derivation. Generic derivation existed in Scala 2. You usually had to use a library to do it. It was very complicated. You'd probably use Shapeless, or you'd use Magnolia. And though they are good libraries, and I have used them, they are limited in certain respects. They assume that your code works in a certain way. If your code doesn't work in that way and GUI doesn't, then they don't really work. Scala 3 makes generic derivation much more accessible. You can actually write the code yourself. You can understand it even. It's amazing. And so it's the kind of code you feel happy writing and happy maintaining, and doesn't have to be sort of relegated to this exotic corner of your code base that only one guru ever touches. So that's generic derivation there. Now, there will be cases when the generic derivation is not sufficient. So how do we go beyond that? So in GUI, we have a layered design. We have this top layer, the thing that we think people will interact with first, which is the generic derivation. It gives you that basic user interface straight off the bat. And this is something that you might have seen in other projects. If anybody's ever used Django in Python or Rails, Ruby Rails, they had this idea of scaffolding, which is creating user interfaces based on data declarations. So it's not a new idea to do this by any means. But usually there's a limitation in the systems like Rails. It generates code for you. So once you've scaffolded it, you've got the code there, and any modifications you make to the code, you can't regenerate the code. You can't easily intermix your own code and the generated code. It's either or, really. Now in GUI, we have a lower layer where we specify the user interface ourselves explicitly, which is a combinator library, a very standard thing. We'll see some examples soon. But critically, we can mix the layers. So we can have generic derivation, and we can say, actually, these are the points I want to change, and we can do that. on a type-based manner. Let's see how that works. So we're using the user as before. Let's say I don't want this slider to collect the age. I'm going to use a text box instead. All I need to do is create a given instance saying there's a component which for integers, int, which is this text box, and then I can use generic derivation again, and it'll pick up this given instance, which is in the scope, and use it in preference to the default given instances. That gives me a user interface like the following. So my name and my age. Okay, obviously not a very good user interface for collecting ages, but it's just an example, a simple example to show the point. So this is showing how we can interleave the two. You don't have to choose one or the other. As again, an example of progressive disclosure here. I can use the generic derivation, and I only need to implement the points that I want to change, which I can do in a type-based manner. So if I can use opaque types if I want to create specific types for different sort of user interface elements that share the same underlying type. I probably wouldn't bother going down there, but it is possible. And that means you only need to learn the GUI components that you actually want to change in the generic derivation. So again, what you need to learn is reasonably constrained here. All right. Okay. Now, there will be times when you want to get into the full GUI component system. So here's an example of how you'd write it. Text box empty, you have the label pet name, and we have slider, which is the rating. So this is for getting pet ratings. Pets rate between 10 and 14, obviously, because all pets are awesome. Just as a reasonably simple code to write. The question is, how can we make this easy to write? I want to talk about that in a moment. And I don't think I have an example of this. No, I don't have an example of this because it's the same as what we've already seen for the user with the age and the name. It's text box and a slider. It's the same interface we've seen before, really. Different context. So how do we make this easy to write this code? How do we make it as easy as possible? Well, let's look at how programmers interact with programming editors. How do people write code? And one of the main ways that people interact with the process of writing code is code completion, the almighty dot. You press dot and you see what comes up. All right, and this gives you a range of options. And you choose between them, hopefully, and away you go. So how can we design to make this easier? Well, let's talk about some of the things. So firstly, this is an example of the principle of progressive disclosure here. So the methods that we see are all the methods that apply to this type. So we're only seeing the methods that are relevant to the type that we're looking at. Is there something else? Yeah, okay. All right, also an example of discoverability. We can find new functionality just by pressing dot and seeing what comes up. What are the methods that are available to me? This gives me an idea of what functionality is available in the library. And we can see here, we have with default, with display, with label, with observer. This gives me an idea of some of the things that I can do. All right, now how do we design to make this process work as smoothly as possible? So the first thing is single import. Single import helps this because some of the functionality is added by extension methods. And because you just have the one import, you always have the extension methods available. There's never the situation where you've forgotten to import some implicit, or not implicit anymore, they're extension methods now, and some functionality is missing. So everything that should be available is always available because we have the single import. The next thing is this fluent interface, sometimes known as a builder pattern, which means we can spend a lot of time just pressing dot. And the third thing is method naming conventions. So let's talk about that. Single import, as already mentioned, gives us all the functionality. Now, the fluid interface, or the builder pattern, is basically maximizing the amount of time that we can just press dot and keep writing our code. And the idea here is that a method returns an updated object rather than doing some destructive updates. Fairly standard in the functional programming world because we don't like mutation, we like copying instead. And there's a few little wrinkles here. So one of the things is that we have these convenience constructors on the companion object, so that you can start constructing just by typing like text box and then dot, and you get some completions, which are the convenience constructors. So you'll see that here when we have text box empty. And then we have more completion with label that returns us an updated text box. Press dot again, we got and so we go. The other bit is method naming conventions. So in GUI, we have some standard prefixes for methods with, add, and for, and they all have the same meaning. So this groups things together in the completion, because the completion is usually sorted alphabetically. So if you know you're looking for something, you type with, and you get all of the with methods there. And you can also, once you learn these patterns, it makes it easier to navigate around. So for example, a with method is changing a property on a component. So if you know that a component has some property you want to change, say the label, you can type with and then search what is it you want to do with label. Right. So here we're leveraging the consistency so we can transfer knowledge between one component and another. Right. So the question we get to is, how do we learn the meaning of these naming conventions? How does one find these things out? And what about other code properties? So there are other code properties in Doodle, such as the fact that all of these methods return copies, updated copies. They're all functional updates. So how does someone come to learn these? Now, I think the typical developer, in my experience, probably not in this room, but in the world of programs at large, doesn't really give much thought to these properties. So my experience working in Java libraries and other libraries is you tend to discover these properties one accident at a time, when something doesn't work the way you think it works. In sort of the SP world, you can have more expectations about how something works. So you can kind of feel the vibes and make some educated guesses about how stuff will work. And that's, I think, fairly common. I don't want to name names, but some projects that don't have the best support for people, but you can still rely on this. And the other thing is you could read the documentation. That's kind of shocking. The problem with documentation, other than the fact you have to read it, which I think, in my experience, most people don't, is someone has to actually go and write it. And when you tell developers to write documentation, you get normally exactly the same response. So how can we make writing documentation easier? Well, one thing that I think should make every developer happier is that there's software that supports writing documentation. So something that's really changed my process is the SBT plugin, SBT type level site, and the associated SBT type level. These are plugins do a huge amount, and in terms of documentation, they provide integration with a tool called Leica, which is a pure Scala tool for writing documentation. So I can write my documentation in Markdown. I can have extensions written in Scala, and it all just works with tools I'm familiar with. I don't need to go to Ruby, Jekyll, or Hugo, Go, and install a different tool chain to build my documentation. It's fantastic. And when I get problems, I can understand what the problems are. So that's the nice thing. The other thing it does is sets up GitHub workflows so that when I commit, my documentation gets updated, and then a few minutes later, it magically appears on my website. So it's all there. And if you use the SBT type level plugin, there's more there around continuous integration and managing releases. And if you work on a open source project, strongly recommend looking at it, and it may well be applicable to internal projects as well. So that is a very useful tool for getting documentation done, and I use it in all my projects. But software is not going to write all the documentation yet. We might get there with ChatGPT type tools in a few years, but for now, we're still probably going to have to write a lot of it ourselves. So some tips for writing documentation. The number one tip is to put the most important stuff first. Again, principle of progressive disclosure here. So for GUI, for example, GUI is a project for implementing GUIs. So the documentation tells you, here is how you do it. This is what you implement. This is what you do. This is the generic derivation, which I consider the entry point to the library, and it's right there as first thing that we describe. In writing terms, this is known as the inverted pyramid, something that journalists use, where you don't put the build-up to it. You don't say, like if you're a journalist describing what happened, you don't say, last Tuesday at so-and-so, an incident happened, and then right at the end, just say there's a car crash. You would say, right at the front, there was a car crash, and then you would talk about how it happened and who was involved and so on. We apply the same thing to documentation for developers. Put the most important stuff up first, then go into all the details and so on. And other tips, developer documentation, not a tutorial. So again, this is really the same idea, but I've read a lot of documentation recently that's written purely as a tutorial. I think tutorials are useful, but when they're tutorials, not when they're your documentation. And a typical tutorial will go something like, we're going to implement something, we'll try this way, it doesn't work very well, we'll try this way, it doesn't work very well. Okay, we'll go to this works nicely. And as a developer trying to get the job done, I don't care about that beginning stuff. I just want the solution. So put that right at the beginning. And then maybe tell me where the solution came from and why it's implemented this way, if I need that additional context. And similarly, developer documentation is not a math textbook. You don't need to build everything up from theorems and lemmas. You can actually state the final result and then give the context. So these are common failure modes I see in probably ST-oriented documentation. If you do write some documents, try not to make those mistakes. However, not everything is just, this is how you use the library. You do need to give the conceptual model. So this is where the properties of code comes in. So for example, the components in GUI are all functional. There's no state within them apart from a few well-defined exceptions. So the conceptual model needs to be in the documentation, and examples on their own are not sufficient. Another common failure case in the scene documentation. So that's what I have to say about human-computer interaction and leveraging it to build libraries. Just run through the key points I made again. So the first thing is a single import. Possibly controversial, I don't know. It'd be interesting to see if other people adopt this, but it's something I'm adopting in all of my libraries now. Just get one import that gives you everything you need. Get going. Second thing is layer design. Can you design it so that there is a very easy to use entry point to the library, but you allow customization, extensions at lower layers if the programmer wants to go there. So that allows you to minimize the learning to get the common cases done, but still provides those entry points for the extension. Third point is designing for code completion, designing so people can press dot and get stuff done. So again, looking here at fluent interfaces, convenience constructors, naming conventional methods to group similar methods together. And finally, thinking about the properties, thinking about the properties of your code. What are the invariants you maintain? What are the expectations people can have about using your code so that they can transfer learning from one spot to another? Final point is write the documentation. Please write the documentation. There's not enough documentation in the Scala community for sure. Okay, so finally I want to talk a little bit about how I see HCI versus code and how some of these concepts are actually things we deal with all the time in programming, but looked at through a different lens. Because as I was doing this, I found it kind of quite interesting that as I got sort of explore these ideas further, I realized there were ideas I already knew from programming, but there's kind of a different angle that human-computer interface people have on these things that I think is interesting. So let's talk about progressive disclosure. It is abstraction. What is abstraction? Abstraction is hiding unnecessary details. What I say progressive disclosure is hiding unnecessary details. So they're the same thing, really. We're used to abstraction in programming, and what progressive disclosure is doing is looking at abstraction, but in a different way, looking at it at the process of writing code rather than the code itself. Consistency is the same. That's definitely a concern in programming. We do a lot of work for consistency, map, flat map, fold, these kind of method names are a big issue. So it's really the same thing going on there. Call it semantics or reasoning sometimes in programming, having simple models we can reason about code with, or having simple semantics. And discoverability, well, this doesn't have any analog in programming that I could think of. And this gets me to the main point here, which is that we have similar concepts, but the difference is that programming, we only talk about the code that is produced. So when we talk about abstraction, we talk about abstractions in the code. And when we talk about consistency, we're talking about consistency in the code. Whereas the HCI point of view is caring about the process. How do we produce the code? So that's where discoverability is different. And that's where we have the slightly different views on things like progressive disclosure, and the difference between the notion of progressive disclosure and abstraction. I think programming in general, we're starting to care a bit more about process. I think people cared about process back in the 80s, maybe when Smalltalk was in its heyday, and we had computer-aided software engineering case tools and things like that. But we kind of stopped caring about process for a bit, now it's coming back. Now we start talking about language server protocol integration, and we start talking about better compiler error messages and that. So now we're beginning to step back and consider that programming as a process is not just the final output. Right, and that's all I have to say today. Thank you very much for listening, and I'll just quickly show the credits for some of the things I used. Glitch effect and the cyberpunk background. Everything else is generated by AI or by me. Okay, well, thank you for your attention, and hand over to questions, Sir Irony.